My name is Frank Lorentzen. I am the CEO of Danish AM Hub. We are a philanthropical foundation supported by the Industry Foundation in Denmark. And we are launching a pretty cool project over here. So if you want to listen to it, if you want to hear more, just come closer and we'll tell you everything about it. Also here I have Kat from Big Architects, who also will present in 5 minutes. Okay. So what you're looking at here is a 3D printed arch. Actually, it's 3D printed arches. And the middle one is enriched and infilled with mycelium, which is a type of mushroom. And why have we done that? It's a really, really good question. I have also been asking myself that a lot the last couple of days, because it has really, really been hard work to get all ready here for the conference today. It is a project where we're trying to push the boundaries and push the limits in terms of also the technology side, but also the material side, and where we are hoping that we can get a lot more out of working with the construction industry, because there are some challenges, as you can see here on the slide, that we have to fix. Now, additive manufacturing cannot fix all problems that we have in the construction industry, but there are two pretty awesome things about additive manufacturing, which is the same as 3D print, just for professional use. One is that you only use the material that you need, because you build it up layer by layer. That's a pretty awesome trait about the technology. And the other is you can do it and print everywhere, anywhere, because you can just move the printer around. These two key traits must be able to create much more positive impact in the construction industry. Actually, when we looked at the numbers, we can see that the penetration of the technology is not that good in the construction industry, and we do need more technology in that industry if we are to tackle some of the challenges here. So we really just had, thank you, one question. How can we get rid of waste by using additive manufacturing? There is a lot of waste, and there is a lot of spatial waste, also in a beautiful city here in Copenhagen. There might be some areas here where we could do more a temporary empty building industrial storage facility. There might be all around the city different places for new types of constructions. And obviously you all know that, but the material waste side of things is awful. It is not good enough. It's not acceptable in the construction industry, and we need to do much more on that. So we thought let's just look at AM and look at where we are today and what we maybe would be able to create in the future. So one is obviously that we can do much more on the flexible and temporary structures, also thinking here in the spatial waste, but also specifically looking at multi-material and biodegradable. As you may know, there is concrete printing. It's really taken off these years here. We have a renowned company in Denmark called Copenhagen that is world leading within that technology. But there are maybe also more that we can do on the different techniques like robot printing, or even having robots to wave different fabrics together. We've looked at all these different techniques and thought of how can we use them, and specifically use them for empowering the design freedom which we have inherent in the technology and the focus on community. And therefore, we created a blueprint for a movement, which is a fancy, really, really fancy term here. But the main idea is to look in a city like this and find different locations here marked in white, where we would be able to use waste, material waste, to create a new building. That's the overarching idea. And then we thought, that is really cool. How do we do it? And kind of the main reasoning behind this is obviously to get the community to assemble and build these, for instance, panels here, but also use the very good and skilled craftsmen that we have, for instance, here in Denmark, and give them a new capability in terms of building and construction method. But if we look at the spatial waste side, you would identify a site, you would look at an empty space, you would have maybe a community workshop, you would engage in the community, and you would co-design some solutions. Then you would look on the material waste that you have in the area, you would process that, you would get it into an AM supplier that again would 3D print the parts, therefore you upcycle the material, and with that you build. Sounds pretty easy, real life it's not. And here it is. Once we're done, the building will look like this. It's you can see the full model over here, and you can see, well, roughly, I would guess, 1/8, 1/9 maybe of the total building here today. There is still work to do, obviously, but I would just like to thank the team in AM Hub for pulling through the last 3 months. We did this in 3 months. I'd like to thank Big for being really, really visionary and having the imagination to really push the boundaries. I'd like to give a really, really large thank you to MDT that in Kolding, a company has these robot printers and has really, really worked hard and been good at getting the really good designs out there in the real world. And obviously also Naturplan. Yes, thank you. Also Naturplan, who has been helping us with this infill of mycelium, which is not an easy thing to do. So last slide from my side is summing up kind of the sustainability part of this. We have in Danish AM Hub spent a little bit of time and money on creating a CO2e calculator. A CO2e calculator that can compare a printed part with a molded part to a milled part. Okay? So you can combine different production techniques, and you can look at it, where are the largest CO2e emissions in a product's life cycle. Okay, does it make sense? And here we looked at our arches, and we also used at a milled product, or kind of a similar arch, but where you would use aluminium and also like a genuine isolation material. And if we look at these numbers, our arch is roughly 81% better in terms of CO2 emissions. So it doesn't emit as much CO2 as we are used to with these materials in the construction industry. One of the problems would be here, if you would manufacture this traditionally, you would have a lot of waste because you would melt each aluminium frame out, and aluminium is a really bad boy in terms of sustainability. And that is, my dear friends, something we need to spend a lot more time on. It's all that waste we need to avoid, and we've really done our best here to try to really push the boundaries on that. So thank you very much, and I'll hand the microphone over to Kat. Thank you.
Frank is a really hard act to follow. He's got a great voice. But I'm here and I'm extremely excited to be also holding the mic closer to my face. Very excited to explain the project particulars just a little bit more to all of you. Again, we're so, I think the next, sorry. We're really excited about the project. And again, I think I just wanted to give a huge shout out again to AM Hub, who have been so supportive and really spearheading the movement. Naturplan, who has done all the research and as well as Lore, our friend here, with all the mycelium, and then MDT to produce all the panels themselves. It's been a true collaborative effort, and I think that's how innovation happens and how invention happens. And I think that's why we're so proud of this project, is it really took a literal village to kind of create the thinking behind it. Yeah. So I think what we are all very interested in with AM technology is how it sits at the intersection, or this niche between kind of bespoke, customized design and the economies that come from scale. I think there's something really interesting about trying to place the technology where it does its job best. And that's something that we've really tried to do by creating a bespoke modular system. And more than that, sorry. The other kind of opportunity for innovation that we found was actually in letting the materials be what they, or letting them do what they do best. So in a way, splitting out the structure from the skin or from the different functions. So instead of printing solid walls of recycled plastic or solid walls of concrete, again, we go back to the idea of reducing waste that Frank has been talking about. We reduce waste by actually just printing what we need for structure, what we need to create the armature of the project, sorry. An almost exoskeleton, which we then can fill with an infill that can also do the best it can in terms of material property. For the enclosure, we knew, we knew we wanted to do something that could actually support the project, but in a sustainable way, and create an impact in terms of how we look at materials and look at kind of how we interact with them. And we wanted something that had a very low footprint and could even start to absorb carbon or be biodegradable in the future. And that's how we turned to mycelium. We wanted to address the kind of issues by concrete, which contributes about 8% of the world's global kind of CO2 levels. And actually, mycelium is nature's cement, and it actually basically binds material together. So using that, we kind of skipped, I think we wanted a bio-based material, but mycelium takes 20 days, while a tree takes 20 years. So in a way, what we've done is we've kind of gone for the vegetarian diet over the steaks, which could be like mass timber. We're looking at something that's a little bit, takes less resources to grow and grows at a faster timeline. And in doing so, I think we also managed to really reduce the carbon footprint of it. So what we're looking at is an exoskeleton with an infill of mycelium, of bio-waste, basically taking trash, again, removing it from the waste stream, and then binding it together with the mycelium. These different arches are only possible through AM technology because each piece is unique. It's modular in the fact that the kind of assembly logic is consistent, but each element has a different shape and a different kind of geometry. These pieces assemble into one arch, and these and again, kind of talking back to the idea of less waste, each arch is self-standing. It doesn't require scaffolding. You can assemble it as a community, as a group of people, or architecture, architects, and some engineers. You can put them together yourself without a scaffold. You don't have to have waste in terms of erecting the structure. And then each arch is then rotated into place with its neighbors, each one leaning on each other, creating a very stable structure. And we're looking forward to actually completing this in a very soon date, hopefully. So I think going forward, we're really excited about this collaboration, about what's come out of the collaboration, about everything that we've discovered in doing this prototype. And again, it's a huge grateful thanks we have for Frank and AM Hub and everybody who's contributed.
Thank you very much. Just a last note on the potential of this project is obviously there's shelters, there's finding this spatial waste and elaborating this system much more and being able to push that, but also from a 3D print enthusiast like myself, within the additive manufacturing community, we have seen a lot of maker movements. So when people suddenly get a printer and get the possibility to do things themselves, they start exploring ideas, they're starting to innovate, they start to share, and then suddenly some great can come out of this. And I'm really hoping that this project, because it doesn't take long time, and then we would have the the panels in a size where it actually would be able to print them on a reasonable, affordable printer at home. And when we have that, we are hoping that we can empower the next generation of makers, being producers or architects or engineers or whatever, and helping them to really take waste, spatial waste and material waste, print new parts and keep them in the system, and always, always keep the overview on the CO2e levels. Is it a good thing or not? Thank you very much, and enjoy the last couple of hours today and the conference in general. And do reach out to us with any questions. You can also just scan the QR codes over here and you'll get much more information. Thank you very much.